Recording in progress.
Yeah, camera on everyone. Let's start off. Perfect. So last thing that we did, we were studying this parallel vectors, equal vectors, zero vector, all that stuff. Great. So before going ahead, there is one more type of vector. So we define this thing is called pseudo vector. Pseudo or actual vector. Everyone keep your cams on. So what is a pseudo vector? So like I said, remember the whole reason why we have this chapter is that, we have seen we actually keep using this a lot. It's like a made up chapter, right? It has a lot of advantages by defining vectors. So this pseudo vector is nothing but a false vector, means it's not a real one. I'll tell you why we had to, create something like this. If something is going in a circle, just imagine, right? If something is going in a circle, this is your x and y axis. Okay, fine. I'll just start removing people from the classroom. I think you guys have no intention of keeping your cam on. So yeah, I'll just kick out. Yeah, perfect. So now tell me one thing. If the particle is here and if it is going up, what will you call this direction as? This is going in j cap, isn't it? This direction is your j cap. What if you're going somewhere here? Then your direction here is minus I cap because you're going to the negative of x axis. When you're here, it is minus j cap, negative of y axis, and here it is I cap. So can you see the problem here? At every point, right, the direction is changing every instant. So if you want to describe the motion of this thing going in a circle, I have to have infinite directions. You're getting the problem there. Now, I don't want to deal with infinite directions. Like I said, we want to keep it simple and easy there. So people said, okay, let's not, do infinite directions. It's a mess. So they came up with something. So it does not give us the actual direction. So the pseudo vector actual direction, but gives us the sense of rotation. We use this a lot in rotational quantities later on. And how do we get the direction? We find this direction by using a right-hand thumb rule. Right. So let's see what is the right-hand thumb rule. We find the direction by using right-hand rule, where the curl of the fingers. Now see, if you're looking into my screen, right, whenever you use a right-hand rule, there are only two directions. See, if you have a hand like this, right, so we have two directions here. So one, the fingers are making a curl, and one is your thumb. That's it. You have only two directions. So the fingers are making a curl and the thumb. So these are the two directions. So this is how the direction goes. So if you're rotating in this direction, so if I'm making my fingers go this way, right, the thumb is pointing upward. Think of like this. Now you're sitting straight, right? Imagine you're turning your head to the left. So what is the rotation? Rotation is going this way, isn't it? You're turning your head to the left. The thumb is pointing up. You're getting it? Suppose if you're rotating this way, I'll show you something with a bottle cap. See, that will be much better. But let me write the full definition. So with the curl of the fingers, so whenever something is rotating, the curl of the fingers will take care of the rotation part. Remember, what we're trying to do, we want to eliminate that infinite directions and create only one single direction. It gives us the rotation. So the curl of the fingers will tell you which way you're rotating, and the thumb will give us the direction. Right, so the picture will look something like this. Look at this thing. So this is what I was saying. You're going to use this in magnetism and everywhere. So this curl of the fingers will give you the rotation. So you have to curl your fingers in the direction of the rotation of the body, and the thumb gives you the direction. So let me show an example. So let's say a particle is going in a circle. So the problem we are facing was what? There are multiple directions. When you're here, it's j cap, minus I cap, minus j cap, and I cap, and so on. So direction is changing every instant. You don't want to deal with this. So you came up with something called a pseudo vector, which is not actually true, but it solves a major problem. What is your major problem? Infinite directions. Right? So this is what we do. So let's say something is going in a circle, 2 revolutions per second. So let's say this particle is doing 2 revolutions per second clockwise. So you want to represent this mathematically with one single definition there. So this is what we do. So it is on a paper, right? So think of like this. So now if you're looking into my screen, so this is the paper there. The particle is going in this circle here, isn't it? So it's going like this. So I will take my hand, I will put my thumb in the direction of the rotation, and this thumb here will give me the direction. So you know how will I write this mathematically? This is what I will write mathematically. We will write this thing as this particle is revolving 2 revolutions per second k cap. But whereas in reality, if you look at this particle is moving in xy plane, isn't it? The particle moves clockwise in xy plane, but you are giving direction in z axis. You're getting the meaning of this. So basically in this thing, this k cap is the direction of the thumb. So if you put your thumb in the direction of k cap, then the curl of the fingers will tell you which way you're rotating. Again, simple example. Tell me one thing. Now you're sitting, right? If you rotate your head towards the right side, can you tell me what is the rotation of your head direction? So which way are you rotating? You're turning your head to the right. So meaning take your hand. So your finger should go towards right, isn't it? Now tell me one thing. Can I put my hand like this and rotate my fingers like this? I can't rotate like this, isn't it? I have to break my hand. So the only other way is keep the finger like this and rotate to the right. When I rotate this way, thumb is pointing which way? Down. So I will say I am rotating my head half revolution downward. But is my head actually going down? No. So the meaning of that is the thumb is pointing down, then the fingers will tell me which way my head is rotating. Look at your fan. If the fan is rotating, can you tell me what's the direction of your fan? Let's say your fan is doing 10 revolutions per second. How will you define the direction? So if your fan is rotating like this, right? So again, same thing. You put your finger in that and rotate it down. Now, if that still looks a little confusing, the best way to do, right? Think of like this. If you have a bottle with you, right? Your bottles are right-hand screws. Your bottles, your screws and everything. Did you ever have this confusion? Sometimes, when you're opening a screw, sometimes you put the screwdriver, rotate this way, it doesn't work. Then you rotate the other way, it works. You ever had that problem? It's confusing, like which way should I rotate? So the simplest way is this. Now look at this. We have a bottle here. You want the cap to come out, isn't it? So put your thumb out. So if you rotate this way, the thumb will go up. So if I rotate the cap this way, it's going to come out. You want the cap to go down, put your thumb down. So if I rotate this way, the cap is going to go inside. This is your right-hand screw, basically. All your bottle caps, all your screws, everything that you use is made for right-handers. So if you're a left-hander, yeah, unfortunately, the world belongs to right-handers. So that's how majority it works. Getting it? So you can think of like this. Basically, the motion of the cap. So when I rotate the cap clockwise or anti-clockwise, so if I'm rotating the cap this way, the direction of the cap is the pseudo vector. So you're getting this thing. So if you rotate the cap this way, see, can your cap comes out? So you're getting the meaning of pseudo vector there. So basically, it is a motion of a screw. Is that making sense? So that's it. So don't worry too much about this. We are going to deal with this again in circular motion, but that is also a type of a vector. So if someone tells you the body is revolving 3 revolutions per second minus I cap, can you tell me how it is rotating? So for revolutions, that I cap is not the actual direction. So if this is your X, this is your Y, and this is your Z, the minus I cap meaning it is in this direction. So put your thumb in that direction. So put your thumb to the left, right? And then rotate your finger, make a fist. So this is the rotation. Are you able to get it? So minus I cap. So if this is your X-axis, this is your minus X-axis, put your thumb to the minus I and rotate your finger, make a fist. So when you make a fist, see, there are only 2 ways you can make a fist. Well, there's only one way you can make a fist. I can never make a fist like this. So it should be always this way. So this guy is rotating in this plane here. Why is that a plane? So this is the direction of the thumb. That's the reason we call it a pseudo vector. It is not real, right? And the particle moves in YZ plane. All clear with this? And the best example is a screw. Whenever you get confused about this, think of a screw. Which way should I rotate the screw so that it comes out? So if you rotate the screw this way, the screw comes out. So this is the rotation. So most of the things are right-hand screws. So your taps, same way. I don't know whether you ever had this problem. When I was in school, right, we always used to have this problem. The water sometimes suddenly used to stop. The biggest problem I used to face as a kid was this. I don't know whether the tap, should I turn that way or this way to close the tap? And if I don't switch it off properly, and if I go, after some time, water will come and the water will start leaking in the kitchen. And evening, my mom will give me right and left. Right. Abhi problem ye tha. See, when the water is there, it is easy. I will turn in one direction. Water come more, hai, so I will tight it more. Water is coming more, I will go in the other direction. But when there is no water in the tap, how do I know? And let's say it is half opened. How do I know which one is the right direction? That used to be a confusion, right? And normally, if it is horizontal, fir bhi you'll figure it out. But let's say the tap is something like this on the wall. Sometimes it gets confusing. So now, same thing. If you want to close the tap, the rod should go inside. So which way should you rotate? This direction, isn't it? Right hand thumb rule. You want the tap to open, it should come out. So that direction. So next time when you're opening the screw of a laptop or anything and you're confused which way to rotate, use your right hand. Right? You want the screw to come out, put your thumb out and see this thing. So you have to rotate the screw that way and the screw comes out. Best example is your bottle caps. That every day you do that, you don't realize it. But there's something which doesn't work this way, you know? If you ever have a Camlin whiteboard marker, those are left-hand screws. They don't work like this. Because you don't want to open them regularly, right? So, except to refill, are left-hand screws. So in that, the thread will be in the opposite direction. If you rotate, it'll actually become tight. Clear with this? So more about pseudo vector, we will deal with it when it comes in circular motion and rotational mechanics. So when you deal with things which are rotating, pseudo vector is good because you don't want to deal with infinite directions. We created something like a false vector, but it solves the problem. Clear with this? Then addition and subtraction of vectors. Any doubt so far? All clear with this? Great. Again, don't worry about it. You'll get the PDF. So focus on listening, understanding, whatever you don't get your doubts cleared and so on. So addition and subtraction of vectors. So you have to be careful. You cannot add vectors like the way you add numbers. So if you have a vector A bar, which is AX I cap, AY J cap, AZ K cap, right? You know the meaning of AX. So the component of X, component of Y, and component of Z. So B bar will be BX I cap, BY J cap, and BZ J cap. So whenever you want to add or subtract the vector A plus or minus B, straightforward. See, think of like this. If I have 3 apples, 4 oranges, and 2 watermelons, right? And in the second box, I have 2 apples, 1 orange, and 3 watermelons. When I add them, how do you add? Add apples to apples, oranges to oranges, and watermelons to watermelons, right? You don't add apples to oranges and all that stuff. So you add all the I components together. So AX plus or minus BX I cap, AY plus or minus BY J cap, AZ plus or minus BZ K cap. So there is nothing much on this. It's straightforward. That's easy part. Yeah. The next thing, resolving a vector. This is important, but you already know how to handle this. If you remember in the beginning, when I said pictorial representation, I can give a vector, something like, I cap, J cap, but sometimes, right, they can also give you the magnitude and the direction. If I say I'm walking 1 kilometer northeast, isn't this a vector? That's a vector, right? I can also say I'm walking 1 kilometer east and then 1 kilometer north. That's also a vector. I can also say 1 I cap and 1 J cap. That's also a vector. So there are different ways you can put it as a vector. So if someone gives you a magnitude and an angle, so if you have a magnitude and an angle and they ask you, what is this vector? Again, go back to the basics. What is a vector? It simply tells you the position. So this thing, what it simply tells you is, this is your x coordinate, which is a cos theta. I hope everyone remembers this by now. The adjacent side is cos theta by hypotenuse, so a cos theta. This is your opposite side, so that is your a sin theta. So if you want to go from O to A, this is how you write it. You travel A cos theta in the x-axis, so we call it I cap. Then you travel A sin theta in the J direction, so that's your y-axis, so J cap. Simple. You just take the components and get the vectors. We have done this before. And now for convenience, we do something like this. So this A bar is actually made of these two vectors, A cos theta and A sin theta. And do you remember when you move a vector parallel to itself, it still remains the same. So we can do something like this. So we can write A bar as A cos theta and A sin theta vertically. That's it, just to make it look good. It'll be easy for convenience. Is that making sense? So this is how we will write the vectors most of the time. Clear? Meaning, look at this thing. Doesn't it look like this? So if you pull like this and if you pull like this, the resultant force will be like this. You can think of like that. Any doubts on this thing? So this and this are exactly same. There's no difference. You can always move the vectors left or right. It doesn't change. So we will write like this. It looks good on the picture. Nothing big deal. All clear with this? Any doubts on resolution of vectors, please ask me. Clear? Perfect. The resolving a vector is quite important. You need to know. It's like bread and butter. It literally comes everywhere. Meaning, so let's see a few examples and small ones, and then we'll go ahead with some good ones. So I'll give you 4 vectors, and you have to tell me what are those. So this is the first vector. Let's say A is equal to 10, and let's say this is 37. Let's say this B is 20 root 2, and this is 45. The C is 6, and let's say this is 60 degrees. D is 4, and let's say this is 30 degrees. So there are 4 vectors, magnitudes and angles are given. Find A bar, B bar, C bar, D bar, A bar plus 2B bar, and 2C bar minus D bar. There, get them all. So when I say get them, I want you to give me answers in terms of I cap and J cap. So this is also a vector. I am walking 10 kilometers at 37 degrees. I am walking 4 kilometers, 30 degrees. So I want you to write them in terms of I cap and J cap and get the components. In case you got an answer, you can type in the chat box to the co-host. And I keep telling you, anytime you don't understand something, you're not clear, please don't hesitate, unmute and ask. If you don't understand a question, it is my fault. You don't know how to do, that's fine. Let's do it together, we'll figure it out. Easy stuff, so let's get this. Yeah. No, actually, I want I cap, J cap, not coordinates. So you should say 8i, 6j that way. Yeah, if you got the coordinates, you'll get that, but yeah. Finish off. This is an easy stuff. It's just I want you to get used to taking the components. No one will ask you like this in the exam. We'll see the actual questions coming up. Okay, let's see. Okay, so basically you're traveling like this and you're traveling like this. So this will be 10 sine 37, which is 6, and this is 10 cos 37. Cos 37 is what, like 4 by 5, and that is 8. So if you want to go from O to A, so that A bar is nothing but you travel 8 units in I cap and 6 units in the J cap. That's it. That's what you do. You want to go from O to B, so you travel to the, you can go up and then you can take a left turn. It's always about going, right or left. Like you have to travel along X and travel along Y. So you can clearly see that triangle. This is 20 root 2, and that's 45. So this will be 20, and this will be 20. I hope everyone is clear with that. Someone didn't get those components, please ask me. I'm assuming, cos 45 sine 45 value, so I'm just skipping. So you're traveling 20 to the left, so that will be minus 20 I cap. And you're traveling 20 in the upward direction, that should be plus 20 J cap. Clear? So up positive, down negative, right positive, left negative. If you're going to the right, I cap. If you're going up, J cap. And you got the magnitude. So that's the straightforward there. So for C bar, so I'll go down because I know 60, and then I will take a left turn. So this would be 6 sine 60, and this would be 6 cos 60. So, and that would be minus 6 sine 60 I cap, minus 6 cos 60 J cap. Sine 60 is root 3 by 2. That would be 3 root 3. And that would be 3 J cap. And D would be same thing, minus plus 4 sine 30 I cap minus 4 cos 30 J cap. And that's 2 I cap plus 2 root 3 J cap. Yeah, that's that. What else you want? You want A plus 2B? So A plus 2B. So multiply B with 2 and add A. So that would be 8 I plus 6J plus 2 times minus 20I plus 20J. That would be minus 40 plus 8 minus 32I. And that's 20, 40, 46J. Then 2C minus D bar. So multiply C there. So numbers are bad. 3 to 3I minus 3J. Minus D is again minus 2I minus 2 root 3J. This would be I cap into minus 6 root 3 minus 2 minus J cap into 6 minus 2 root 3. Yeah, you can leave it like that. All clear with this? That's it. So I just took up some random numbers and you got the components. Ananya. Confused? Which part? A, B, C, D or the summation ones?
So D1.
D के लिए what to travel? Maybe I did a mistake here. Let's see. So this is 30 now. So I will go down and then I'll go this way. So this will be 4 sine 30, opposite side, and this will be 4 cos 30 downward. So right is positive, 4 sine 30 I cap and minus 4 cos 30 J cap.
Sir,
Okay.
C bar, can you please explain that C bar?
C के लिए what to do? Ananya, clear the D bar? Yeah. Dave, see now, if you want to go from here to here, what to do? Go down. And this thing. So simple thing, see. Which side is touching 60 degrees? The down one or this one? The down, right? Y-axis. So that is adjacent side now. Whichever side touches the angle is adjacent side. So that will be cos. The other one will be the sine. Right? So are you sure of the triangle? I can draw it to you if you want. Like, see. Get used to this thing stuff. So this is 6 and this is 60 there. So this is a component here, 6 cos 60, and this is 6 sin 60. Clear? Left and down. So the formula is cos theta. Ha, Ananya, don't see the formula. That's not formula. Forget about the formula. Don't think in terms of formula. Think in terms of like this. You're traveling horizontally and you're traveling upright. You have to see that. What if this is given as theta? You're getting it? It has nothing to do with the formula. That is just a theta there. Clear? All got this? Easy stuff. Let's see. Now, how they can frame questions on this thing. Now, let's define something called equilibrium. I'm sure you studied this in school. What is equilibrium? When the net force is zero. A body is said to be in equilibrium I hope you're getting it. It has nothing to do with the formula. It is always about what is your x coordinate and what is your y coordinate, right? That's how you have to think. The body is said to be in equilibrium if sum of the force vectors acting on the body is zero. Is a zero vector. Quite a useful thing. We will again encounter this in NLM also. So if you have a body, and let's say if there are multiple forces, F1 bar, F2 bar, F3 bar, and F4 bar. And if you add all these forces, if you say this body is at rest, F2 bar plus F3 bar plus F4 bar must be a zero bar. Now, here we can even say something more. If you take the component of forces in any direction, meaning, for example, if I take a line like this, and if I say this F1 ka component in this direction, F2 ka component, F3 ka component, F4 ka component, all those components must cancel out. Component of forces in any direction cancel out. Why? What happens if they don't cancel out? Think about this. In a particular direction, if the forces don't cancel, means what? The body is going to go in that direction, right? And the body is going to go in that direction. Can you call it as an equilibrium? No. So as straightforward as that. Clear with this. So how do we solve these kind of equilibrium problems? So step one. Steps to solve equilibrium. Step one, choose your body. Sometimes you'll find 2 to 3 bodies, so it doesn't matter. Choose your any body there. Choose your body and define your x and y axis. See, you can choose your x and y axis however you want. Right? You can choose your x and y axis like this. You can choose your x and y axis like this. Nothing wrong. It's all arbitrary. It is just your sense of direction. The only thing you have to be careful, both should be perpendicular. Right? You can choose your x and y in any direction you want. Then, step two, resolve your forces. So if there are 4 or 5 forces, resolve the forces along x-axis and y-axis. So basically, you're resolving them to I caps and j caps. And the third point, the sum of the forces in equilibrium sum of the forces along x and y are zero. When you do this, you get two equations. Solve the equations. Let me show you one problem as an example, and then we'll go ahead. We'll do one easy one. So let's say we have a body there. So we have a block. So someone is applying a force, F1 bar, 10 newtons in the left-hand direction. And let's say you're applying a force, 10 root 3 newtons in the y direction, and there is a force F here at an angle theta. The question is this: find F and theta if the block is at rest. Meaning these three forces are acting 10 newtons left, 10 root 3 newtons down, and there's a random force F at an angle theta. Okay. Step 1, choose your body. That is the body. Step 2, choose your x and y axis. This is my x and this is y. Done. Step 2, resolve the forces into components. So when I take this, I'll just take a point there. This is force F. This is theta. How do we resolve? Remember, see, the side whichever touches the theta side is what? Cos theta. So this is F cos theta. The other side automatically becomes F sin theta. Is everyone okay with this convention? F cos theta, F sin theta. What are the other forces? You're acting 10 to the left and 10 root 3 to the down. Bas ho gaya? These are all the forces. Now, in the vertical direction, that is in the y direction, what are the forces? F sin theta is up and 10 root 3 is down. Since the body is not moving, shouldn't these two forces be equal? F sin theta should be equal to 10 root 3 or else the body will go up. In the horizontal direction, F cos theta and 10 must be equal. If they're not equal, then the body will go to the right or left. So we got two equations, equation 1 and equation 2. Step 4, solve the equation. Now how to solve? From here, its physics is over. Now it's all max. So I can square the equations f square sine square theta plus f square cos square theta will be 10 root 3 square, that is 300 plus 100. So sine square theta cos square theta is 1. This will be 400. We get f is equal to 20. Once you get this, put it in equation 2. This will become 20 cos theta is equal to 10. Cos theta is equal to half. You can do this much faster, but yeah, I just wanted to show you how to get the steps. So the force must be 20 newtons and the angle must be 60 degrees. Is the idea clear, everyone? Is the process clear? So this is the steps we follow. Please have a look at the steps. Ask me if you're confused here. So step 1, choose your body. Step 2, choose your x and y axis. Step 3, resolve the forces along x and y axis. And then you say along x axis they should balance, along y axis they should balance, and you'll get equations and you'll solve. Any doubts so far? Clear. Radhika, Manav, clear with this? Rohit, Shrikant, Tanmay, Ananya, Prisha, Dave, clear? Perfect. Then let's go ahead with some questions. So we got a block here of 10 kg. Right, we can, so this is one string here, tension T2. This is another string here, tension T1. So these are strings. And let's say this angle is 30 degrees. And the weight of the block, mg, which is 100 newtons. So we are going to take g as equal to 10. So if they don't mention anything, take g as 10. So this block is hanging, between the two walls at rest. So T1 and T2 are the tensions in the string. The block is at rest. Find T1, T2. Same question, 10 kg block. But this time the strings are like this. This is 53 degrees and this is 37 degrees. This is T2 and this is T1 and the weight is 100 newtons. There, A part and B part, get them both. Let's get the first part. I'll give you 1.5 minutes for the first one. This T2 string is horizontal, huh? The T2 is horizontal. This is how the questions will be framed. No one will give you a vector and ask you find the components. So like I said, vector, the component thing is just like an application there. 200 and 100 root 3. Okay, that might be right. Let's check, but get the second one also, Prashant. I don't know the answers for that. So that thing would be T1. T1 you got 200. Yeah, I think that's right, Prashant. First one you got it. Get the second one. Remember the process. Step 1, choose your body. There's only one body there, so kuch problem nahi hai. X and Y axis are regular ones. T1 ka components, T2 ka components. Vertical, horizontal. Solve. Right, Ahana, you got it. The first part you got it. Tanmay got it. Get the second one. I hope you guys remember the values of cos 53, sin 53, sin 37. It's a 3-4 triangle. In case you forgot, that you can note it down. Like this is a 3-4 triangle. For people who don't know what is 37 and 53, we take them because the numbers are good. That's it. 37 and 53 are not any special or anything. Okay, let's see the first question. Step 1, choose your block. So my 10 kg is there. Now, if that is 30 degrees, this is also 30 degrees. Do you guys agree? Now, when you take the components here, so this is T1, this is T2. This angle is 30 degrees. So this component will be T1 cos 30. So whichever side touches the angle is the cos one. The other one becomes the sine. And this would be your 100 newtons. Perfect. So in the vertical direction, T1 sine 30 must be balancing 100. Sine 30 is half. Therefore, T1 is 200. In the horizontal direction, T2 will be T1 cos 30. But what is T1? T1 is 200. Substitute here. That would be 200 cos 30 is root 3 by 2. 100 root 3. I hope everyone's clear with these calculations. Right, Ishi, you got the second one also. All clear with this? Ananya? What about the second one? 53 and 37. Siddharth, clear so far? Siddharth, clear with this thing so far? Great. Let's get 37 and 53. We have one answer. Anyone else? Same story. So if that is 37, this is 37, that is 53, this is 53. So when you take the block into components, this will be T2 cos 37. This will be T2 sin 37. Please check. In case you didn't get the components, please ask. This will be T1 sin 53. This is T1 cos 53. And this would be 100. Please check. This is how it looks. Nahi, Anish, that is wrong. So in the vertical direction now, not one, two people are balancing. So T1 sin 53 plus T2 sin 37 is balancing 100. Please check your equations. If you got the equations right, the physics part is right. That means you must have messed up the calculations. the horizontal direction, T2 cos 37 must be balancing T1 cos 53. You're getting, see, two people are pulling up one weight, so that 2 must be equal to mg. Everyone is convinced with the equations. Anyone not clear with the equations, please ask. Right, Karthik. So what is sine 53? Sine 53 is 4 by 5. Sine 37 is 3 by 5. Is equal to 100. What is this guy? T2 cos 37 is 4 by 5. T1 3 by 5. So from here we get 4 T2 is 3 T1. So I can write T2 is equal to 3 T1 by 4. I will take this and substitute in this. I can send 5 that side. This will be 4 T1 plus 3 T2 will become again 3 T1 by 4 is equal to 500. That is 4 4 is 16. 16 plus 9, 25. 25 T1 by 4 is equal to 500. We get T1 is equal to 80. If T1 is 80, then I put it back here, T2 will be 60. Please check. This is how I solve equations. I don't do all that simultaneous equations and all nonsense. Get T1 or T2 from one equation and dump it in the other equation. So yeah, that's just like you will see which works for you. You can figure out from there. All clear with this? Right, Siddharth, got it. Any doubts on this? Rohit, Manav, Dave, Ananya? Clear? Shrikant, Tanmay, Radhika? Let's see one more. Let's say we have an incline like this. This angle is theta. This angle is also theta. We have a ball here, and the ball got stuck between these two inclines. Right? So this thing is applying a force N1 here. So this is 90. This is applying a force N2 here. This is also 90. So these forces will be perpendicular to this, and you have your own weight mg. So I'm not giving you any numbers, right? So there's a ball which got stuck between the two walls. Are you able to visualize how it is? So there are two inclines like this, and the ball is stuck between them. And the angles are theta and theta. Find N1 and N2. Story is still the same. Choose your body, right? Choose your X and Y axis. Resolve the forces. Horizontal force will balance, vertical force will balance. Just get me the equations. Don't simplify it. If you get the equations, it is sufficient. If I give you numbers, solving will become easy. But just get me the equations. There. This is how you should act.
Question actually, my network is
There are two inclines. You can see the picture, right? So horizontal floor, incline, and incline. And the angles between them are theta. Right? And here we got a ball which got stuck between the inclines. So find N1 and N2 if the ball is at rest. Are you able to see how the picture looks like? How the ball got stuck?
Yes.
If I have to show you, it looks something of this sort. See, if you're looking into my screen, it looks like this. So this is the something like this. Yeah, you understood. It got stuck between this. So if this is your incline, it's stuck like this. Able to see this? So that way. Anyone still not clear with the picture, please ask me. Do one thing. Forget about the N1 and N2. Can you give me N1 and N2 in terms of I cap and J cap? Start from there. Give me the vector components of N1 and N2. Let's say you already know N1 and N2. Give me components N1 cos theta I cap, N1 sin theta J cap, like that. Just give me like that. It's all geometry here. There is less physics, there is more geometry here. Think, take a minute or two. Try to figure it out. It's completely fine if you don't get it. I'm going to show you anyway. But I want you to think for a minute, try to figure it out. Whatever you can handle, do it. Someone got the components. Go ahead. Tan theta ng. Interesting. How did you even get those answers? Ananya and sin theta. Nee, Ananya. You got the angles wrong. Okay, let me show you the picture. Let's see one at a time, okay? First, let's see only N1. Look at this. So for N1, if I drop this line straight backward, isn't this a right angle triangle? No? And if this is theta, this angle will be 90 minus theta. That means with the vertical, this angle will be theta. Everyone agrees? That means if this is your N1, and that is theta, so the vertical component will be N1 cos theta. The horizontal component will be N1 sin theta. Any doubts on this? So if you want to write this in the vector form, N1 bar is given by minus N1 sin theta because it's pointing backward, and plus N1 cos theta J cap. This is the vector form of N1. Everyone clear with the angles? Now, same thing if I do for N2, now look at this thing here. I will extend the vector N2 from here, straight going down. Now, this is the right angle triangle, isn't it? This whole thing is your right angle triangle starting from here. Then if this angle is 2 theta, now see if this angle is 2 theta, that means this angle is 90 minus 2 theta, isn't it? That means with the vertical, this angle will be 2 theta, right? So this angle is 2 theta. So same thing. So again, by geometry here, so if you see the vector N2 is like this. So if you draw the vertical component, it will be N2 cos 2 theta. The angle is 2 theta there. And this thing is N2 sin 2 theta. Please check those things. So the angles are not theta for both of them. The angle becomes 2 theta for that. So if you want to write N2 as a vector form, N2 vector form will be minus N2 plus N2 sin 2 theta I cap minus N2 cos 2 theta J cap. Please check your vector form. All clear with this? That's how you get it. So you just have to make a triangle there. So here I make a triangle with theta. There I make a triangle with 2 theta. So all about geometry there. Now if you try to solve this, you can do. But let's be very clear with the picture. Everyone is convinced with the picture. Everyone has understood what is happening here. This is how we will use the resolution of vectors. We will just not do I cap, J cap. That's nonsense. Like that is the basic stuff. That's not how you want to learn. This is how you want to apply. But any doubts on the picture? Anyone is not convinced, something is not clear, please ask. Clear? No, great. Now once you got the components, let's try to solve it. So if these two are the forces and mg is downward, so what are the total forces? So weight vector will be minus mg j cap, isn't it? That is the three vectors. Since it is an equilibrium, n1 bar plus n2 bar plus mg bar, the weight vector, I just call it w bar, must be 0. Be careful, huh? Never say n1 plus n2 plus w is 0. That is wrong. You have to say n1 bar plus n2 bar plus w bar is 0. Right now, you can add the vectors. You can, all the I components should cancel. So this will be minus n1 sine theta plus n2 sine 2 theta I cap plus n1 cos theta minus n2 cos 2 theta minus mg j cap. You're saying this is 0 bar. How can this be 0? If your I component is 0 and j component is 0. Agreed? Any doubts so far with the equations? This is your 0 bar. So x-axis, this should be 0. That means this has to be 0 and this has to be 0. So we got a n2 sine 2 theta must be equal to n1 sine theta. Now again, little geometry. Anyone remembers what is sine 2 theta? 2 sine theta cos theta. Where did we get this from? Remember this formula? Sine 2a, 2 sine a cos a. You're getting it. Things will keep going front and back. You need to remember your stuff. You forgot. Again, I'm telling you, see, if you forgot, it is completely fine. There's nothing wrong in forgetting it. But now, since you forgot, after the class gets over tomorrow, revise it. Forgetting is not a problem. What you do after that matters more. You forgot, and after that, you don't do anything. Now, that's nonsense. Forgetting is completely fine. Getting it? So, n1 sine theta will cancel. So, you end up with 2 n2 cos theta. Like I said, it becomes more of a max at this point of time. So that's your equation 1. The second one will be n1 cos theta. That's what I said. If I give you numbers, it would have been easy. If I give theta is equal to 30 degrees, it would have been easy to solve. mgn, but what is cos 2 theta? So you can replace here n1. So I can take this n1 substitute here. This will become 2n2 cos square theta minus n2 cos 2 theta is equal to mg. So we get n2 common, we get 2 cos square theta minus cos 2 theta is equal to mg. But we also know what is cos 2 theta. What is cos 2 theta? Cos 2 theta is 2 cos square theta minus 1. You can keep playing with this. So I'll put a reference here, page 15. Should check it out. For page 15 basic math. Yeah, we did only one chapter so far. So cos 2 theta is 2 cos square theta minus 1. So if you substitute here, we get n2 2 cos square theta minus 2 cos square theta minus 1 is equal to mg. Interestingly, this guy will cancel. You end up with n2 is equal to mg. If n2 is equal to mg, then n1 is nothing but 2 mg cos theta. Those are your answers. Now, unfortunately, exam mein final options will look like this. Right? So you can't say, oh, how will I solve all this equation and everything? This would be a pretty good mains level question even when you're in 12th. So clear with this. But did everyone got the components part? I think this was the main key. Once you got this, the rest of the thing is just max. All clear with the steps?
So, sir,
Haan,
can
Shrikant.
you explain one bar one more time, please?
Which part?
This one, yes, sir.
Which part?
The first part, the N1.
The components.
Yeah,
So be specific now. This one meaning you're saying this. How did it take this components?
yes, yes, sir.
This is N1, right? N1 is pointing this way, no? So this is theta, isn't it? So this is the adjacent side, N1 cos theta. This is the opposite side, N1 sin theta.
Yeah,
The angles are confusing. See, this was N1. This was theta. So how will we take components? Which is the adjacent side? This one. That is
yes, sir.
N1 cos theta. This is the opposite side, N1 sin theta.
Thank you.
Sure? Hmm.
Yeah, okay.
I know there are a lot of angles that you have to be a little careful there. So any other doubts on this? All clear with this? It's a good one. So we can keep playing more like this. So take a break. After the break, we will do a few more like this. So come back by 9:40. Any doubts so far? Anything not clear? Please ask. Or else you can go away from the screen for some time and come back by 9:40. Sure, I'll see you by 9:40 then. ठीक है देख लो कल सुबह तक कुछ हो गया तो इन्फॉर्म कर लो स्पीकर से तबीयत खराब हो गया तो मत हेलो हेलो हाँ सर हाँ हाँ थोड़ी थोड़े नहीं वो है बाहर डस्ट और सब पर देख लो ठीक हो गया तो ठीक है बट तबीयत खराब है तो मत आना ठीक है वो ट्रेन में वो सब करके आओगे और 3 दिन छुट्टी लोगे बेटर एक दिन लो ठीक है चल ठीक है Chalo, let's start off. Camp on everyone. Let's see one more. Let's say we have a wedge here and we have a ball here. So this ball got stuck between the wedge and a wall. I hope you're able to visualize the picture here. So we got a ball which is stuck between a wedge and a vertical wall. Mass of the ball is 10 kg. I'll just say mass M. So all answers will come in terms of M. And this point where the ball is touching, it actually touches at a single point. I couldn't draw it properly. It's a tangent, right? It just touches at one point. This height here is 2r by 5. And this is the lowest point of the ball. From there to the ground level is r by 5. So this would be the lowest point of the ball. Now, if you look at the ball here, the wall is pushing horizontally. So this is the force due to the wall. I'll call it N wall. And the incline is also pushing. Remember, these forces will be towards the center. Along the normals, right? Normals always meet at the center. So you'll get one more force here. This will be your N incline. So I'll just call it N2 and I'll call it N1. So this is the force due to wall. And N2 is due to this incline, the wedge. And there is also the gravity, mg. So basically, these are the three forces. So N1, N2, and mg. What about the angles? I didn't give you the angle. So the whole question is you have to figure out the angles now. Find N1 and N2 if the ball is at rest. I hope the picture is clear. We have a wall to the right side, right? Radius of the ball is r, mass m, and radius is r for the ball. So this ball got stuck between an incline and a wall. The wall is pushing with N1, the wedge is pushing with N2. So N2 is at an angle. The point where the ball touches the incline is at a height of 2r by 5. The lowest point of the ball from the ground is r by 5. Using this data, you have to find N1 and N2. In case you're wondering what the hell is happening, do one thing. Start with this. Can you find that theta? Start from there. Find theta. Theta is the angle made by the incline. So using this thing and geometry, you have to find theta. Start from there. Once you got theta, then you can take components and then you can all do that stuff. But let's get theta. So the first part of the problem is geometry. The second part is physics. Third part is AN max. So let's start with that. Find theta. Because of it, that theta, you can't take any components. Find the angle made by the incline with the floor. Try. I'll give you 1 or 2 minutes. I'll give you 1.5 minutes for the angle only. Get it. Anyone not convinced with the picture, the diagram is not clear, anything you're not sure, please ask. Okay, anyone figure out the angle? Shreyansh. Yeah, Shreyansh, you got it. So that would be what? Sine theta 4 by 5 is what? 53 degrees. You got the angles. Yeah, now let's get N1, N2. Let's see how to get the angle. So a little geometry there. So we got the circle here. This was the floor. So this is some random point here where it is touching, and you're saying this is 2r by 5. The lowest point here is r by 5. So from the center, now if you drop this thing, this is also r, isn't it? Because that is a radius. This is also r because that is a radius. Now, if you take this angle to be theta, so it will be the same angle theta. I'll show you how you'll get that. Let's say that is theta, right? So how much will this length be? You can clearly see this length must be also r by 5. If that is r by 5 and the total height is r, I didn't draw up to scale properly, but then this length must be 4r by 5. Is that making sense? So in that triangle, we can clearly see cos theta is the adjacent side, which is 4r by 5. The hypotenuse is the radius r, which is 4 by 5. So we get theta is 53 degrees. Any doubts on this? Understood how we got the angle? We just made a triangle there. Now let's prove this theta is that theta. So this is the incline there. So if I call this point as A, so this was A. This is 90 degrees. This is theta. Right? So this angle will be 90 minus theta. This angle will be theta. It is the same thing. Sure? We don't need it though, but yeah. Any doubt so far? Everyone got the angles? And then the question is straightforward. Let's draw the body again. So this is the body. This is the center. So this is your N1, the wall. This is your N2. And we got this angle is theta. If that angle is theta, this angle is also theta, alternate angles. So N2 ka components will be, N2 ka vertical component is N2 cos theta, that is the side touching the theta. This will be N2 sine theta, the opposite side. And your own weight, mg, is acting downward. Plus, check it out, that is the other three forces. In the vertical direction, N2 cos theta must be balancing mg. Therefore, N2 will be mg by cos theta. And cos theta is how much? 4 by 5. That's 5 mg by 4. Similarly, in the horizontal direction, N2 sine theta is N1. But what is this thing? N2 is 5 mg by 4. This is sine 53. Is N1. Sine 53 is 4 by 5. So N1 is mg. Any doubts on this? Wait, I think I did a mistake. This is 37 degrees, my mistake. Cos 4 by 5 is 37. This is 37. I was wondering why it is looking weird. This is 3 by 5. And one is 3 mg by 4. Yeah, that was the answer. My mistake. So first thing is to get the angles. Second thing is to get the component. The component part is easy once you get the angles. Any doubts on the process? All clear with this? Clear, na, Ishi? Manav? Rohit? Prisha? Clear? Let's see one more like this. This time, let's say we have two identical spheres. So we have two balls here. Both of them got stuck between two walls like this. Right? Two identical spheres of mass m and radius r. Definitely make sure to try them again on your own. To maybe tomorrow or day after tomorrow, take a rough paper and make sure to solve. Little difficult to get ideas in the beginning, but once you see a few of them, you'll get the hang of it. Right? So the distance between them is 3r. The distance between the walls is 3r. And each ball ka radius is r. Now, what will be the forces? So this is N1. This is the force due to the left wall. And both the balls are pushing each other. So this ball is being pushed up. Let's call it N2. This is being pushing down N2. Newton's third law, right? Both the balls push each other. So N2 is the force between balls. This is your N3 and this is your N4. So there are total 4 forces now. Find N1, N2, N3, N4. So we have two spheres of same mass, M and M. They both got stuck between the two walls. The distance between the walls is 3r. So N1 is the force due to the left wall, N3 is the force due to the right wall, N4 is the force due to the floor, N2 is the force between the balls. So maybe for convenience, what we'll do now, let's call this thing as ball A, and let's call this thing as ball B. So we will know which ball we are talking about. So N2 is pushing the ball A up, and N2 is pushing the ball B down. Take a minute, first think about the question, try to absorb the question. How do we even start? Now, when you saw the question for the first time, you must have got some weird feeling like, oh, what the hell, right? That is important. That is important because advanced exam, that's what you're going to feel. So step one, what to do? Not to panic. Step one, don't panic. Read the question, take a minute or two, understand as much as you can. If there are 5 steps in the question, figure out at least one step. You don't get anything, that's fine. I'm going to teach you in the end. So that's the whole point of the class. It is not to solve questions and it is not to compete with me. N2 is not 0, Rishi. Think about it. Meaning, suppose if I put you there in the beaker position and if I throw your brother on top of you, he won't exert any force on you. It's like that. It's like your brother jumping on you. How do we approach? Think that, and then I'll give you some more ideas and then I'll give you more time. In this, there is one value among N1, N2, N3, N4. There is one of that. You can just see and tell the answer without doing anything. You can see and say, this is the answer. You can calculate Shreyans, whatever you want. I give you all the values you need. But listen to this thing. Out of N1, N2, N3, N4, there's one of them you can see and tell the answer without,
Or is
if
it
you
X?
actually, you have to type your answers.
Oh.
Right? You got something, please type your answers. So there is one thing here where you can just see and tell the answer. So Tanmay, nee Tanmay, that's not the answer. Nee Shreyan, that's not the answer. Anish, you're right. Rohit, you're close by Rohit. You messed up something. You got the one right, but the value is wrong. What do you guys think? You should type your answers. Right? It is good. At least get a wrong answer, right? That's a good thing. If you get a wrong answer, you're thinking of something, right? Then at least we know your thought process was wrong. But at least you're thinking. That's the best part. I want you to think. Get wrong answers. Big deal. If you don't do mistakes in the class, then when will you do? Doing mistakes, you learn faster. But do smart mistakes. Don't do dumb ones. Don't do random guessing. Inky, pinky, ponky. So A is the answer. That's bullshit guessing. Don't do that. There is one thing here, N1, N2, N3, 4. You can see and give some logic with a, just a statement and get the answer. No need to solve, no need to do anything. Nay, Anish. I'm telling you, you can tell an answer. You can give me a value. Nay, Shreyansh. I think you must have solved it, na, that thing. I think you got that from solving. Maybe that could be right, but I'm not asking that. Listen to my logic, okay? If I choose the whole system, right? If I take the whole body here, N1 is pushing this way, N3 is pushing this way. Fine. N2 is pushing up, N2 is pushing down. So these two will anyway cancel. Agreed? If you take the whole body. Now look at the whole thing. The weight is acting mg down. The weight is acting mg down. N1 is horizontal. N3 is horizontal. N2, N2 got cancelled. Who is balancing all this weight? The only person who can balance this entire weight is N4, isn't it? There is no one else who can balance the weight of the balls other than N4. Therefore, I can simply say N4 must be equal to 2 mg. Is that making sense? Is that argument making sense? In the vertical direction, there are only three forces, mg, mg, and N4. That's it. There is no other force in the vertical direction. If you take the two balls together, is that logic making sense, everyone? Ananya, that makes sense? No. Let's say your weight is 40 kgs. Your brother ka weight is 20 kgs. If he is standing on top of you, or if you're holding him, and if I ask you, what is the force on your legs? Isn't the force on your legs your weight plus your brother ka weight? Because the entire weight is balanced by you only, right? So even though the ball A is sitting here, end of the day, iska weight will fall on B and uska weight niche hi aayega na. The N4 only has to balance everyone. So N4 should be the total weight, isn't it? And the best thing about this logic, you know what? I can put 1,000 balls and I can still tell you the answer. So later on, when we actually do an NLM, right, the questions will be like this. There is one ball here, there is one ball here, and there is one ball here. 3 balls got stuck. So we will say the same thing. We will say this force will be 3 mg. Saves you time, but there, every time you need not solve, you can use some tricks. Anyway, so that is one thing. So next thing, so how do we even start? Can someone find me this angle? If you don't know angles, you can't divide into components. Can you find that theta? Start from there. I think someone did figure it out already. Nay, Karthik, that is wrong. Priyansh got it. Let's start with that. Get me that angle theta. If you don't get the angles theta, you can't resolve into components. So it always starts with getting an angle. How do I get that theta? I think, Shreyans, if you do that, then your N2 is right. Get the remaining values, N1, N3. They're not really, yeah, I know they're different. Don't say it is scary. They're just different. It's a good thing, right? You are getting used to it. See, I'll tell you one thing. If I give you 10 questions, this is for everyone. Listen to one thing here. If I give you 10 questions, and if you got all 10 questions, what does it mean? It means I'm not teaching you anything. As simple as that. So don't be happy like, if someone is teaching you and you're getting 10 out of 10 questions, boss, no one, that means the person is not teaching you. Right? And if you're not getting even one single question, means you're getting to learn a lot. If you're getting 2, 3 questions, means you're doing well. If you're getting, I think 4 or 5 questions, I think it is fine up to that point. So be happy when you're not getting questions because you're getting to learn something new. Because think of it this way. What if this exam comes in the final exam? Then what would you have done? So it is better to get slotted in the class so that you can do well in the final exam. So be happy when you get to see something new, you're seeing an approach. Because I can't tell you how the final exam will be, the final paper will be. For your seniors currently, right? They have an advanced exam next month. I don't know the paper. No one knows the paper. So for them, when I'm doing the revision, literally, I am taking questions from physics Olympiad, Russian Olympiads. I'm picking questions from so many different weird sources. When I read that question, I myself get baffled, like, what the hell are they even talking about? And the point is that you need to get used to that feeling. It will be uncertain. Unfortunately, in a school, everything used to come from textbook, right? So there used to be a kind of confidence. Ye book kar liya to I know I have done everything. Advanced you can do everything and still feel there is something more. So let's get this. So yeah, Aishi, you got the angle right. It's just geometry, everyone, getting the angle. So if someone is feeling it is too hard, ask yourself, after explaining, are you understanding or not? You're understanding, then I think you're doing fine. So that's great. After the class gets over, tomorrow take a rough paper and resolve. The question becomes yours. That's what you're trying to do. Let's see the angles. It's again little geometry. Now, the first thing, right, the distance between the walls is given, and this is important, meaning if you change the distance, I can mess up the angles. So from the center till here, what is this distance? R. From center to here, what is the distance? R. What is the distance between center to center? 2R. Everyone agrees till here? And now you're telling me the distance between the walls is 3R, then shouldn't this distance also be R? Because this is R, this is R, this is R, that is 3R. And if that is R, this is 90 degrees, this is theta, cos theta will be equal to R by 2R, that is 60 degrees. Everyone is convinced with the angle. I think you got one part right. Perfect. Once you got the angle, your job's done actually. Now it is about components. So let's draw for each one. Let's draw for A first. So this is the Eka ball. What are the forces? This is your N1, which is pushing from the left. This is your N2, which is pushing like this. And we found out this angle is 60 degrees. And this weight is mg. But there are only 3 forces on N1. What is N2 ka component? N2 cos 60, N2 sin 60. Please ask me if you're confused with the angles or the components. Once we got this, in the vertical direction, who is balancing the weight? N2 sin 60 is balancing the weight. Sin 60 is root 3 by 2, so this will become 2mg by root 3. Who is balancing N1? N1 is balanced by N2 cos 60. But what is N2? We already got this, substitute here. Cos 60 is half, which is mg by root 3. Any doubt so far? Then we can draw the diagram for B. Now, how will the B ka picture look like? So on B, someone is pushing with N2. This is 60. You're pushing with N3 and you're pushing with N4. So if that is 60, This is 60. So just now we got the component. This will be n2 cos 60. Newton's third law. Look at this. N2 sin cos 60 is this way. N2 cos 60 will be opposite. But it's fine. Even if you don't know that, it's just about taking components. So n2 sin 60. And your mg is done. That's it. You're got there. So horizontal direction, what are the forces? N3 is being balanced by n2 cos 60. N2 is mg by root 3. So that's mg by 2 root 3. Wait, this is N1, na? That is mg by root 3. You can solve N4 is nothing but mg plus N2 sine 60. You can solve this, you'll actually get 2 mg. So there's no need to calculate N4 separately, but anyway, that's how the equations will come. Please have a look at this. N2, N3, N4, right, Ishi, you got it. Who else got it? Shreyans, I think you got N2, right? N2, 2 mg by root 3, yeah, you got it right, yeah. But please have a look at this. You should definitely try this on your own. Take a rough paper, give it a try. You will get stuck, that is fine. Struggle for 3-4 minutes, and then you can check out the solution. Then your brain will register it. All clear with this? In case someone is finding it really hard and difficult, this is a good way, good opportunity, right, to discontinue. Like you can just talk to Vimeo and leave the batch, right? Better leave before than after 3-4 months of struggle. If you see when the class started, we had around 16-17 people. 2 people already left. Those people just joined for demo, they couldn't handle it. So that's a good thing, right? Your competition is running away already. And we didn't even start 2 weeks only. So that's a big advantage you have already. But yeah, we can't bring down the advanced level, but we can take you to the advanced level. So you will handle it. These are, you just see, I'll tell you one thing. These are not difficult. You're not used to it. In school, technically speaking, physics, they should have taught like this. If you learn like this for 3 months, you'll think this is normal. Right? Like that. Try to solve it on your own and then see next chance. Tomorrow evening, take a rough paper and try to resolve the questions. You guys have a wrong misconception. You guys think like, I will just sit there and suddenly my brain will start processing and I'll get ideas. For your brain to process, you already need to have certain models. Tomorrow, if you become an architect, right? Do you think day one, they'll give you a building inside design? They will teach you 100 different designs. They will show you 100 different buildings all over the world. So the idea is this. When you encounter a problem, you're going to say, okay, this thing, right? This problem we faced, in that American building. So maybe we can use that solution for this problem. So you need some kind of material for your brain to think. So the brain does not think in vacuum, right? For example, the next question. Now, if you have not seen anything like this, if I modify the question, I'll tell you simple things here. I give you this question, but when I give you an exam, what I will ask you? In the exam, I'll just put like, there is a big ball of radius 2r and there is a small ball of radius r. And the distance between them is 4r. Isn't the question identical? For a change again, a model. That's it. Exam, I'll ask you this, you're done. Or maybe I'll ask you this, I'll say there are 3 balls now. Okay, a new question. So it's not like I'm covering all the models. I'm just giving you a framework for some models. So if something changes or something modifies, you know how to handle it. Cube of side A. So we got a cube here of side A here, and we got a mass M in the center. We attach one string to this corner, we attach one string to this corner, and we attach one string to the face center. So we have 3 strings. So this is A, this is B, and this is C. Again, let me explain you how the picture looks like. Now look at this. Look at the wall in front of you. You're sitting, right? Look at the wall in front of you. Now look to the left corner, that is A. Look to the right corner, that is B. Right? And the wall behind you, exactly behind you, the midpoint is C. Can you guys see the 3 points now? The wall in front of you, the two corners, up, left and right, are A and B. The point exactly behind you, behind the wall, is point C. Are you guys able to visualize the 3 points? And you took a particle of mass m and you're hanging in the middle. So this particle m is hanging in the middle of the room, attached by 3 strings like this. Right? This is a mass m. So a mass m is hanging at the center of the cube. With strings attached at ABC. So let's say this string cut tension is T2. These two strings are identical, so let it be T1 and T1. And the weight of this ball is mg. So these are the 4 forces. Find T1, T2 in equilibrium. T1. Okay, you got some T1 there. T1 mg by root 2. No. Ishi, you might be right. Give me the T2 also, then you can confirm. Not required, Shreyansh. You can actually just do with the components, remember? But यहाँ पे components आएगा in 3 directions, X, Y, and Z. So idea is that only. All the components in all directions should cancel out. Think. Take a minute or two. See how will you handle this. But everyone is able to visualize the picture, right? Again, I'm telling you, don't worry about getting the answer. You're not competing with anyone. Just aram se focus on thinking. I'm giving you time for that. It's completely fine if you don't get anything. Enjoy the process. Just ask yourself, okay, what should I do? Should I be that way? What is that? Ask questions. When you ask questions to yourself, you will start thinking. Nee, that is wrong. Karthik, you got the second one right, but the first one is goofed up. नहीं अनिश क्या किया तूने कुछ भी किया should I don't know Hannah, you can figure out whatever you want. Like question is find T1 T2 come magnitudes, right? This is the whole question and the information. Exam you can't ask the examiner what is this. So I'm giving you 2-3 minutes, so figure it out. You have doubts about the question, please ask. How to do that anyway I'm going to tell you. Nee, Anish, that is wrong. Root 3 mg by 2. What is that, Shreyans? T1 or T2? Trisha, you got it, Trisha. Yeah, one answer. That looks right, Shreyans. Again, it's to do with the geometry again. It's all about getting angles. Let's get the angles. Listen carefully, yeah? So this corner is B, right? So okay. So this is B. O is the center. Now from here, if you drop a line, this is 90 degrees. Do you guys agree with this triangle? Can you see how it is a triangle? So you're joining the center. Again, look at this. The wall in front of you, right side ka corner, from there to the center and to the middle of the wall. So I hope you can see the picture there. Now, how much is this? This is A by 2. How much is this? This is A by root 2. I hope you're getting why that is A by root 2. Because that is the face of a square. See, if you take a square plate, that is a half diagonal. This distance here is A root 2. That's an half diagonal. And you're asking for half of it. So half of it will be A by root 2. This angle will be theta. And we can see Pythagoras theorem, root over A square by 2 and that thing, this would be A square by 4 plus A square by 2 multiply 2. This would be, OB will be root 3A by 2. So from here, we get cos theta is A by root 2, root 3A by 2. A will cancel, that would be root over 2 by 3. Sin theta would be 1 by root 3. There, these are your angles. These are not standard angles, there are some weird angles. But there, check out this theta. Anyone confused with theta, please ask. Right, Ahana, you got it.
So how did you get A by root 2?
That is half diagonal. When you drop from center to the edge of this thing, isn't this an half diagonal? No? This is your half diagonal. Yeah, all got theta. Great. Then let's get the components. Now see how this picture looks like. Huh? So this was your mass M. So the string is pulling with T to this side. And what about this components here? Now this corner here, look at this thing. If this was your T1, remember this was your T1, the components would be T1 cos theta and T1 sin theta. Meaning here you'll have two components here. So this component will be T1 cos theta and the vertical component will be T1 sin theta. This component will be T1 cos theta. There is one more vertical component T1 sin theta. So there are two T1 sin thetas which are pulling it up and there is one mg downward. Are you guys able to visualize how the forces are? So it's like the Y shape, right? See, if you're seeing in my screen, there are Y shape here. So we get two components flat and two components up. You get a Y shape here. And this is again another angle there. We'll talk about that. Now in the vertical direction, who is balancing it? 2 times T1 sin theta is balancing mg. And what is sine theta? 1 by root 3. So the main thing here is getting the angles. After that, you have to divide the components into two parts. What about the horizontal direction now? Now for the horizontal direction, let me draw it again. Can someone tell me in a square, if you drop a bisector like this, what is this angle? 45 and 45? Because in a square, total is 360 and each part 1/4 will take 90 degrees. So that must be 45, 45. It's like 1/8 of a 1/8 of a square, isn't it? Or in case you didn't figure it out, this is a by 2, this is a by 2. So tan theta 1, so that's 45. So you can do however you want that. Now, what are the components here? So basically you're taking यहाँ पे components का components. This is T1 cos theta. This is T1 cos theta. Now if you resolve this into components, in this direction we get T1 cos theta cos 45. इसका component will be T1 cos theta cos 45. In this direction we get T1 cos theta sin 45. And this will be T1 cos theta sin 45. And this was your T2. There you can clearly see the sin 45s will cancel out. You will be left with 2 times T1 cos theta cos 45 is T2. 2, T1 ka value we already know, root 3 mg by 2. Cos theta ka value we know from here, root over 2 by 3. Cos 45 is 1 by root 2 is equal to T2. Interestingly, 2 will cancel, root 3, root 3, everything goes off. You get T2 is equal to mg. So step 1, get the angles. If you observe, right, in all the questions if we see, this is a common theme. We have to get the angle. And how do you have to get an angle? Look at the question, you'll see something. The forces are at an angle, right? The forces are not straight, right? They're not horizontal, they're not vertical, they're at an angle. यहाँ पे भी देखो ना, the force N2 is at an angle. But for some reason, if you see, previously I used to give you angles, now I suddenly stopped giving angles. So that should have, triggered, okay, without angles, how will I get N2 ka horizontal and N2 ka vertical? That's your first question. Then you will say, okay, that means I need to get the angle. Then comes geometry. Now, how to get an angle, that max you have to figure out. Once you get the angles, then the job is simple. Choose your X, choose your Y, horizontal, vertical, equations, solve. Is this clear, everyone? So this shape, what you're getting, right, in chemistry later on you'll learn, this is the PCl5 molecule ka shape. You have a phosphorus, you have a chlorine, and you have a chlorine like this. So the shape would look something of this sort. They call it something bihedron, tetrol, something, the tetrahedron types. But clear with the components, everyone. This is how we should learn resolving a component. So this is how we will need applications. Meaning you guys are thinking like this, but later on when we actually do stuff, this is just the starting part. So you'll get used to it, but things will be something of this sort. Look at this thing. So we will have like something like this. We have a rod, we have a cylinder, we have an incline. You can see how the forces are. N2, F2, F1, N1, mg. You will find n number of forces. So what we're doing, right? We are doing it like slowly. We are reaching that. So you will get used to it. It's not tough. You're seeing it for the maybe first time, so you're finding it a little weird. But it is manageable. But still, most of you are getting answers. You're getting stuff. So clear with this? Yeah. Then I think, yeah, ठीक है. So that is one. ठीक है. So with that, we'll wrap up for the day. And from next week onwards, right, I'll be giving you access to the testing platform. Next Monday when we catch up, I'll give you the access. Right. And after that week onwards, we'll be starting our tests. So the first test will be based on basic math and vectors. Not full vectors. Maybe I'll tell you what is the portion also. I'll send you the portion also. But we'll be starting off our testing from next week. Next week. So I'll tell you how the test goes, how much time you'll get, what everything I'll explain you on that. So don't worry. Okay, so whatever we did, especially right, again, tomorrow spend some time, take a rough paper, just resolve them again. See the question, try to do it again, right? Even if you got it, try to do it again. You will understand what I'm trying to say. Okay, that will wrap up for the day. Next class, when we catch up, maybe we'll do one or two more, and then we'll go ahead with something called triangle law, parallelogram law, and all that stuff. Wait, let's do one thing. I'll give you one homework question. Do that and come. Next class, we can discuss. Let's say we have a cube. Cube of Seidel. Now what you did, you tied this to the ceiling with 4 ropes. So A, B, C, and D. There, you have tied it to 4 ropes with point. The length of each rope is also L. That means OA, OB, OC, OD is also equal to L. The mass of this block is capital M. Now, in the second thing, you got another idea. You said, okay, why should I tie the block like this? Why don't I do something like this? I will take the midpoints of these sides, E, F, G, and H. So these are the midpoints there. You did the same thing. You tied it again to O. So both the cases you're keeping in equilibrium. So here also you got OE, OF, OG, and OH is also equal to L. It is an identical block, same mass M. So remember, side of the cube is L, the ropes are also L, everything is L. Now, when you actually calculate, you will notice the tension is not same. So in this, the tension will be T1, T1. So these ropes are identical, so they'll have tension T1. Now here you messed up the ropes position, so this is a different position. This is T2, 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 and T2. Right, so these are midpoints, okay? E, F, G, H are midpoints. Right? Looking at it, you're getting a feeling they might not be same. So find the ratio of T1 by T2. In case you're wondering, how does this look like? Let me just show you this. Did you ever see this thing? You carry stuff with an helicopter like this. Can you see how they're carrying the block? That block of 4 strings are from the 4 corners. So what if I don't connect like this, but I connected the midpoints? Is that thing clear? So the tensions will be different in both the strings. So find T1 by T2. So try this as a homework. So when we catch up next Monday, first thing in the class, we'll be doing this and then we'll go ahead. Okay, with that, we'll wrap up for the day. So any doubts, anything else, please stay back and ask, or else you're free to leave. I'll see you guys again on Monday, same time. So yeah, and please make sure to resolve the thing, whatever we have done so far. So any doubts, anything else, stay back, or else you're free to leave.